again to Let's Talk Chemistry with Pastor Dan. We're looking at a lab today, so we're looking at the Alkaline Family Lab. So I have a copy of the lab right here. So what we're going to do is we're testing the Alkaline Family Magnesium against the non-Alkaline Family Aluminum. And we're trying to see how the differences exist between these two metals. First, we're going to put them into a test tube and add water and then heat it, add phenolphthalein, and then see what happens. And then we're going to ignite them both or heat them both up, take the ash and do the same thing. I'll also do calcium. And the reason why I did calcium as opposed to have the students do it, because the fact that it's a little bit more violent reaction. So the pre-lab question, make sure we understand what's going on. There's a data table of everything we need to look through. So copy down, couple questions, and the conclusion. All righty. So copy that if you want to. And here's each step of the lab. So let's start with calcium in water demonstration. So let me open this up a little bit wider so you can see it a little bit better maybe. Oh, that doesn't want to. Yeah, let's just go with it right there. All right, so inside of there is water. And I'm not going to heat it because the reaction itself will generate enough heat all by itself. So we're going to take a piece of calcium, which is right there, and we're going to drop it down so it goes inside of the water. Now, once it goes in there, if you look carefully, you'll notice it's beginning to bubble. The reaction there is forming calcium hydroxide and hydrogen gas as the calcium reacts in a single replacement reaction. We'll talk about later. And the reaction becomes to become a little more energetic. If you were to touch the bottom of the test tube, you'll find that it gets extremely exothermic because that's one of the characteristics of and you can see there, it's beginning to generate a lot of energy. Now, we're going to use an indicator here. The indicator is phenolphthalein. And phenolphthalein is used to identify the presence of bases. In the presence of acids, they're clear. Neutral, they're clear. But in the presence of a base, you get that purple color. So what that's telling you is this reaction generates a basic solution in the reaction and something specific was done. So that is the calcium. That's the one that goes all the way to the bottom of that chart. Next, let's do magnesium in water heated, and then we're going to use the indicator, phenolphthalein again. So here we go. And we're going to take and put the magnesium's in a ribbon and get it to slide down to the bottom where the water is. I think I have to pull it out, but I have to heat it this time because magnesium's a little bit higher up the reaction chart, so it's not quite as energetic. So I slide it up there. The lab says to heat for 2 minutes. I find as long as you heat till it begins to boil, you should be good. So we see it's beginning to heat up the water enough to cause a possible process to take place. So we get a good reaction. I turn the heat off. I'm going to add the phenolphthalein. Is a reaction taking place? Did it become basic or is it unreactive? Let's see what happens. You'll see there it is basic in nature. All right, let's do the aluminum. This is the non-alkaline metal. So let's see what happens here. Okay, I have a test tube out this time because I knew it was having problems. So I put the aluminum piece inside of the water directly. Slid it back into the heat source, begin to heat it up. So again, just heat it long enough to get it to begin to boil. I think I need to move it around a little bit. There we go. Should be good to get it begin to heat up. Here we go. We're starting to see some energetic reaction actually heating thermal energy as the water gets heated. We're only seeing bubbles. We're not seeing too much at all. Add the phenolphthalein in this time. You see nothing happen. So the reaction didn't take place like it did for the alkalines. All right, now, what we're going to do now is we're going to heat the magnesium piece up and the aluminum piece up with a Bunsen burner and see what happens. Now, if you were to look at this directly, I would tell you not to look at it. Look off the peripheral because the light is quite bright. So here we go. That's magnesium wire there strapped in to a heat clamp. And take my Bunsen burner over. Now I heat it just the point where I begin to get it to react. There it goes, bright, bright light. It's going to fall off from the heat clamp into my evaporating dish there as it completes the reaction. And we're going to generate magnesium hydroxide ash as it burns. All right, now let's test the aluminum, see what happens there. So again, we have the aluminum strapped into the heat clamp. Again, same as we did with the magnesium. Bring my Bunsen and burn over. We see a little bit of a red, but that's just heating. I don't see any reaction, no excitation, no definite reaction. It's not nearly as energetic as the alkaline metal. All right, let that finish up. All right, now we're going to take the ash from the magnesium oxide that we had in that evaporating dish, that little porcelain dish. And I'm going to see that I put it into water. See, that's the ash down there, magnesium oxide. And I'm going to add some phenolphthalein to it. Again, we see a purple color, that indicative that a reaction takes place, that their solution is basic in nature. All right, let's try the same thing with the aluminum oxide, the aluminum piece. So it's also in my water right there. You can see the aluminum. I put the N2O piece in. There wasn't any ash. No reaction to the phenolphthalein. All right, so go back through, finish the rest of the lab. Hopefully that wasn't too bad. Help that showed the excitation of alkalines as opposed to non-alkaline substances. Take care. Be good. Bye.